Okay, this is Thursday's lesson. Just a few more examples on how to solve log problems. Just a few other different kind of scenarios. We're going to start when you have log written out a couple times on the same side of the equal sign. If that happens where they're on the same side, you should try to condense it down to just one logarithm. And then from there, you can do the swooping, turn it into an exponent, and all that. The only remaining thing is to always check your answers. And if any of your answers makes it log of a negative, then that would be extraneous. So you want to make sure that your answers, when you plug them back in, would always be log of a positive number, not log of a negative number. So we'll do a couple examples, you'll see what I'm talking about. So right off the bat, let's condense this down. Addition condenses into multiplication. So we can condense this one down to log base 3, and then we're going to multiply the x times the x minus 8. Addition condenses into multiplication. Now we have a log, a single log. It's isolated, so I can swoop. So I can do 3 to the second equals all of that. So 3 squared equals x times x minus 8. So then we've got 9 equals, when I distribute the x through, I'll have an x squared minus 8x. Now in order to solve that, it's a quadratic, so I need to get everything on one side. So I'm going to subtract the 9 over to the right side. And then I'm going to look and say, can I factor this? And it looks like I can. I can think of two things that multiply to negative 9 and add to negative 8. And that would be a negative 9 and a positive 1. So that means my solutions are 9 and negative 1. But I always have to check my answers. So if I plug a 9 in, I'll have log base 3 of 9. That's log of a positive. If I plug a 9 in here, I'll have 9 minus 8, which is 1. I'll still have log base 3 of a positive, so that's good. But check out this one. If I plug a negative 1 in, then I'll have log base 3 of a negative number, and that's no good. That's an extraneous solution, so we cross it out. Okay, this one, very similar. I have logs multiple times on one side of the equation, so I'm going to condense them down. Addition condenses into multiplication. I'm going to have natural log written just once, and then I'm going to multiply the x minus 2 times the 2x minus 3. And I can bring this up as an exponent, so I can write this side as natural log of x squared. Now I have log written on both sides of the equal sign, so it's like we can drop those and just make the x minus 2 times 2x minus 3, set that equal to the x squared. So on the left side, I'm going to FOIL. I'm going to get a 2x squared minus 3x minus 4x plus 6. And it's a quadratic, so I want to get everything onto one side. So I'm going to subtract the x squared over here. 2x squared minus x squared will get an x squared. Combine the x terms for a negative 7x plus 6 equals 0. Can we factor this? Can we multiply to 6 and add to negative 7? Let's see, we could do a negative 6 and a negative 1. That would work. So that means x equals 6 and x equals 1. Now let's check them. If we plug a 6 in, we'll have natural log of 4. That's good. If I plug a 6 in here, that'll be a 12 minus 3, which is 9, natural log of 9. That's good. But check out the 1. If you plug a 1 in, 1 minus 2, we get a negative number. That would be log of a negative number. And if I plug a 1 in here, I'll get 2 minus 3. I'll get a negative number again. So that's extraneous, no good, cross it out. Okay, I love this problem. Lola deposited some money into an account that pays 5.25% compounded continuously. That means we're using PERT. How long will it take her to triple her money? Okay, so here's our rate. We always have to move the decimal place 2 to the left, so it'll be 0.0525 when we plug it into the formula. That goes in for R. What's going to go in for P? That should be the original amount, but I don't see that written anywhere up here how much she deposited originally. All I notice is that we're going to triple her money. So whatever goes here, 3 times that amount will go here. So if I left it as a P and I put the 0.0525 in for the rate, whatever P is, I'm going to triple that amount, so that would be 3P over here. I mean, I could, as a side note, we could just make up an amount. Let's say she deposits $100. If we triple that, she'd have $300. You could do it that way if you want. You can make up any amount you want, triple it, that goes over here. Because look what's going to happen. We would need to get rid of that 100 to isolate this exponent. So we would have to divide by 100, and we're going to get a 3 over there. The same thing is going to happen if I divide by P. I'm still going to get a 3. So it doesn't matter whether you make up an initial amount or if you just leave it as a P and then put a 3P over here. Okay, now we're going to continue the problem. So it's an exponent. When we swoop it, it's going to turn into a log. So log base E of 3 equals 0.0525t. Log base E is the same thing as natural log. We can type natural log of 3 into our calculator, and when you do that, you get 0.19403. Oops, nope, you don't. You get, sorry about that, let me erase that. When you type natural log of 3 in your calculator, you get 1.09861. And then we have to get the t alone, so we're going to have to divide by 0.0525. And we're going to get, in the end, we're going to get 20.9259. And I'm going to assume that t is in years, so 20.9 years, about, for her to triple her money. Okay, last problem. The yield V in millions of cubic feet per acre for a forest at age t years is given by that equation. Find the time, so we're solving for t, necessary to obtain a yield of 1.3 million cubic feet. So V is in millions, so we're going to plug 1.3 in for V. So 1.3 will equal 6.7 e to the negative 48.1 divided by t. Okay, I have to isolate this exponent, so I need to get rid of the 6.7. Let's just divide that out right away. Okay, so 1.3 divided by 6.7. Okay, now we have the exponent isolated, so now we're going to swoop. It's going to turn into a log base E of 0.19403 will equal negative 48.1 divided by t. When you type this in your equation or in your calculator, you can type in natural log 0.19403 and you will get negative 1.63974. And we're trying to solve for t. So we could put this over 1 and cross multiply. So you'd have negative 1.63974t equals negative 48.1. And then to get t alone, we're going to divide by negative 1.63974. And we will end up with t equaling 29.339. 3339. And that would be years, because I believe it says years right here, age t years. Okay, so that's it for now. Your homework is on your assignment sheet. I might change it. I'm recording this on Sunday night. I might change it. If I do, I will post the altered assignment on Haiku. But as of right now, it's listed out on your assignment sheet. This is Thursday. This is 3.4 day 2. Okay, I'll see you tomorrow.